Okay, here we go. Inverse functions. The first thing I want to do is talk about some motivation behind why we need inverse functions in the first place. All right? Suppose we need to know what the weather will look like this week. On Monday, the temperature will be 75 degrees Fahrenheit, but suppose we need to convert this temperature to Celsius. To do this, we can use the following formula. All right? C equals 5/9 times F minus 32. Okay? What we can do is we can take this value 75 and plug it into the F slot. All right? And then see what we get for C. All right? So we get this. And when we put this into a calculator, it works out to a value that's super close to 24. All right? So 75 degrees Fahrenheit corresponds to 24 degrees Celsius. All right? Now suppose that we have all the temperatures in Celsius for the rest of the week, but we need to convert these temperatures to Fahrenheit. All right? So these are the temperatures. And we already found here on Monday that 24 degrees Celsius corresponds to 75 degrees Fahrenheit. All right? So let's move to Tuesday. And we can use the same formula again. All right? Only this time, we're going to plug 26 in for C and then solve for F. All right? So let's hone in on this equation here and get rid of everything else. All right? Let's take this to the top of the screen. To isolate F, the first thing we need to do is multiply both sides by 9/5. All right? And when we do that, we can see that the 9s are going to cancel. All right? And the 5s cancel as well. All right? So that leaves us with 9/5 times 26 equals this business in parentheses, right? F minus 32. Okay? So then, to isolate F on the right-hand side, we can add 32 to both sides. All right? And that gives us F equals this. All right? And when we type this into a calculator, we get a value that's super close to 79. All right? So we successfully converted from Celsius to Fahrenheit. All right? But that took a lot of work. All right? And we have 3 more temperatures to convert: Wednesday, Thursday, and Friday. All right? Plugging in values for C and solving for F 3 more times is doable, but it would be tedious. All right? Evaluating is easier than solving. And what do I mean by that? I mean, I want to come up with a function that we can evaluate quickly. All right? Doing that is faster than going through all those algebraic steps to isolate F. All right? So in the formula C equals 5/9 times F minus 32, the Fahrenheit temperature is the input, and the Celsius temperature is the output. All right? We need a new formula for a new function where the Celsius temperature is the input and the Fahrenheit temperature is the output. All right? So we need to swap the input and output. This concept of swapping the input and output is the idea behind inverse functions. All right? So let's take a look at the official mathematical definition of an inverse function. All right? For any one-to-one function, f of x equals y, all right, it has to be one-to-one. That's a requirement. A function f inverse of x is an inverse function of f if f inverse of y equals x. All right? So we're taking x and y and we're swapping their positions. All right? This can also be written as f inverse of f of x equals x for all x in the domain of f. It also follows that f of f inverse of x equals x for all x in the domain of f inverse. All right? So when we perform this function composition, we start with x and we end up with x. All right? Same thing right here. All right? And we'll take a look at these equations more closely in the next video. All right? Note that f inverse of x does not equal 1 over f of x, all right? This is not an exponent right here, right? This is not saying to take f to the denominator of some fraction and raise it to the 1 power. No, this is just the notation we use to talk about the inverse function, all right? And not all functions have inverses, all right? Because not all functions are one-to-one, all right? So let's visualize this, all right? Let's go back to our function machine drawing, all right? Here's the function f, and here's the function f inverse, all right? If I take x and I plug it into f, and then I turn the crank, all right, what comes out is y, all right? And then if I take that number y and I plug it into the inverse and I turn the crank, right, the inverse function does its thing, and what it spits out is x, all right? It spits out this value that we started with, all right? That's what the inverse function does, okay? And this will make more sense when we take a look at specific examples for f and f inverse, all right? F of x equals x cubed, and f inverse of x equals the cube root of x, all right? These functions are inverses of each other, and we can show that using algebra. All right, we'll talk more about that in the next video. All right, for now, what I want to do is just take a look at the function machine drawings to visualize the concept of inverse functions, all right? So let's plug a concrete value into the function f, all right? If we plug 2 into f and turn the crank, right, that's when the function does its thing. The function says to take what we're given and cube it, all right? So when we turn this crank, we're cubing the number 2, right? And 2 cubed is equal to 8, all right? So f is going to spit out 8, all right? And then if we take 8 and we plug it into the inverse function and then turn the crank, right? F inverse does its thing, right? And it says to take what we're given and take the cube root of it, all right? So what's the cube root of 8? The answer is 2, all right? And this is what always happens, all right? We start with some value, we get out another value, plug that into the inverse, and what comes out is the value that we started with, all right? Let's look at one more example just to really drive the point home, all right? Let's try plugging in a 3, all right? When we plug 3 into f and turn the crank, what comes out is 3 cubed, which is 27, all right? So f spits out 27, all right? And then we take that number and we plug it into the inverse and we turn the crank. What comes out is the cube root of 27, which is equal to 3, all right? So we started with 3 and we ended up with 3. That's what happens with inverse functions, all right? Next, what I want to do is revisit the Fahrenheit and Celsius example. All right? Here we're asked to find a formula for the inverse function that gives Fahrenheit temperature as a function of Celsius temperature. All right? So this is the formula that we were given in the beginning of the video, right? C equals some expression in F. All right? Let's give this a name. All right? Let's give this function a name. Let's call it h, all right? H of f equals this, all right? Write this down in your notes because we're going to use it later, all right? We have a blue function, h, and a red function, h inverse, all right? So let's take a look at what h does, all right? Remember, a function is a mapping, all right? H maps the value 32 to 0, all right? So when we plug a value of 32 in for f, right, we end up with 0. All right, we end up with c equals 0. Okay? And the function h maps the value 50 to 10. And it also maps 86 to 30. All right? Try it out in your notes to confirm. All right, let's make sure my math is correct. All right? So we know how to convert F to C, right? We know how to go in this direction, okay? But what if we want to go in the opposite direction, right? How do we convert C to F? We need to come up with a formula for H inverse, all right? What's the inverse function? That's the question. To get that formula, what we need to do is hone in on this equation here, all right? So let's erase everything else, all right? Hone in on this equation right here and use some algebra to isolate F. All right, let's get F in terms of C, right? F equals some expression in C. That's what we want, all right? So let's take it over here and let's multiply both sides by 9 over 5, all right? When we do that, the 9's cancel, all right? And the 5's cancel as well, okay? So that leaves us with 9/5 C equals F minus 32, all right? And then we add 32 to both sides, all right? And that gives us F equals this expression in C, all right? And what I want to do next is simply swap the left and right hand sides, all right? Let's say that F equals this expression in C, all right? And this is the answer to the question, right? This is a function that gives Fahrenheit temperature as a function of Celsius temperature, all right? But I want to take a closer look at this function, all right? Let's take this equation and take it to the left side of the screen, all right? And then let's bring back this picture that we had before, all right? We're trying to convert C to F, right? Going from right to left, okay? H inverse is the function that makes this mapping happen, all right? So let's give this formula a name, all right? Let's call it H inverse, all right? It's a function of C, right? Because this is an expression in C, okay? And let's see what happens when we plot the blue function H and the red function H inverse on the same plot, all right? So we have the blue function H of F and the red function H inverse of C, all right? Here's my plot, all right? Here's the CF plane, all right? And I want to start with this blue function, all right? Let's plot this blue function. What is it going to be? Well, if we distribute this 5/9 to each piece in here, we'll end up with 5/9 F plus some number, I don't know what that is, but that is in the form y equals mx plus b, all right? So it's a line, okay? The blue function h of f is a line, and this is graphed right here, okay? One thing that's really interesting about inverse functions is that their graphs are reflections across the line y equals x. All right, in this case, I have the line c equals f. C is like y, and f is like x. All right, so this is the line y equals x. And the graph of the inverse function is going to be a reflection across this line, all right, across this dotted line. Okay, but before I plot it, there's one thing I want to do. All right, and this is going to be a little bit controversial, maybe a little confusing, but it's okay. Let's walk through this together, all right? I'm going to take this function and replace the c's with f's, all right? Why am I doing that? It's because I need this function to be an expression in f, right? To plot this line, it needs to be a function of the independent variable f, all right? I haven't changed it, right? This is still the function we can use, right? It says to take what you're given and multiply it by 9/5 and then add 32 to the whole thing, all right? I'm not changing the function, right? I'm just changing the variables so that it makes sense when I plot this thing on the CF plane, right? It's some function of f, all right? And we can see that it's a perfect reflection across the line c equals f, all right? We'll take a look at more graphs in the next video. But for now, I just wanted to introduce the concept of an inverse function and show you what they look like on the graph. All right? That does it for this video. Thank you for watching. and like and subscribe.